Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about greedy algorithm design strategy of module 10. In this module, we are going to discuss about two algorithms. One is Prim's algorithm and other one is Krishkal's algorithm, which are used to find minimum cost spanning trees. So as part of today's session, we are going to see first Prim's algorithm. Let us see the Prim's algorithm. Before going to explain about Prim's algorithm, first we need to know what is a spanning tree, right? So what is a spanning tree? A spanning tree of a connected undirected graph is a tree that includes all vertices of the given graph. A spanning tree of a connected undirected graph is a tree. It must be a tree. It should not be a graph. A spanning tree of a connected undirected graph is a tree that includes all vertices of the graph. And in other words, how we can say is, it's a subgraph and it is a tree and it connects all the vertices of the original graph. What the vertices present in the original graph, all vertices should be there and all those vertices should be connected. Okay, so now how we can define a spanning tree in a more detailed way means, a spanning tree is a subgraph of graph G which has all vertices covered with minimum possible number of edges. So if it is having minimum possible number of edges means definitely it becomes a tree. So hence a spanning tree doesn't have any cycles and it cannot be disconnected. So a spanning tree can be found in various ways, but it's essential to know that a graph can have multiple spanning trees. So here you can see an example. Here G is the given graph which contains multiple spanning trees. Here this is one spanning tree, this is another spanning tree, and this is another spanning tree. This, suppose for example, if you are seeing the first one, this is subgraph of G, and this contains all the vertices which are present in G. And this is a tree. It is not a graph. It is a tree. That is, it doesn't have any cycles, and it is connected. So that's why it becomes a spanning tree of this graph. In the same way, this also. So a graph may have multiple number of spanning trees. Right. Now here, what is the cost of a spanning tree? If we assign any weight, some weight to the edge, that is to be called as weight connected undirected graph. Now suppose for example, in this graph, if the weight assigned to the edge AB is 10, so here the weight assigned to this edge is 10 and the weight assigned to this edge is 15 and the weight assigned to this edge is 9, then what is the cost of spanning tree means? Sum of weights assigned to the edges. Now here this is 10 and this is 9. If I add these two, the cost of this spanning tree becomes 19. Right. Now coming to this spanning tree, here the weight assigned to this edge is 15 and the weight assigned to this edge is 10. So the cost of this spanning tree becomes 25. Now coming to this tree, so here the weight assigned is 15 and here the weight assigned is 9. Now the cost of this spanning tree is 24. Right. So what is the cost of a spanning tree? Cost of a spanning tree means sum of weights assigned to the edges in the given spanning tree. Now, what is minimum cost spanning tree? What is minimum cost spanning tree? So, if we find a graph may have number of spanning trees, if we find the cost of all those spanning trees, whose cost is minimum, that spanning tree is called as minimum cost spanning tree. Suppose in our previous example, if you see our previous example, this graph is having 3 spanning trees and the cost of this spanning tree is 19, the cost of this spanning tree is 25 and the cost of this spanning tree is 24. Out of the 3 costs, whose cost is less? This spanning tree cost is less. So that's why this spanning tree is to be called as minimum cost spanning tree. Right. Now, here you can see for this graph, so earlier we seen a small example. Now, if you see somewhat complex example, which contains more number of vertices and more number of edges. Now, for this, the minimum cost spanning tree is this one, right? Like that, the minimum cost spanning tree may be present. So, a graph may have number of spanning trees. A graph may have number of minimum cost spanning trees also, but the minimum cost is same. But the minimum cost is same. Right. Now, in our greedy method, we have two algorithms to find the minimum cost spanning trees. The first one is Prim's algorithm, and second one is Driscoll's algorithm. So first here we are going to see Prim's algorithm. So for understanding this Prim's algorithm, just I'm going to play a small video. Try to understand that algorithm.
Then from A or B, what is the shortest path to an unvisited vertex? B to D is the shortest path. Now from A or B or D, what is the shortest path to an unvisited vertex? D to C. Then from A or B or C or D, what is the shortest path to E? A to E is the shortest path. So we already visited all vertices. This is the minimum cost spanning tree with cost 34.
So, by seeing this, you maybe understood something about the Prim's algorithm. Now, I'm going to explain the steps which are present in Prim's algorithm, how Prim's algorithm works to find minimum cost spanning tree. Now, in case of Prim's algorithm, we start with one vertex and we are going to keep adding edges with the lowest weight until we reach our goal. Our goal is to find minimum cost spanning tree. Till we find the minimum cost spanning tree, we will keep adding the edges with the lowest weight. Now, here these three steps are to be repeated in case of Prim's algorithm. First, we need to initialize the minimum cost spanning tree with a vertex chosen at random. So, one vertex from the graph is to be chosen random. So, first we need to initialize this minimum cost spanning tree with that vertex. Now, find all the edges that connect the tree to new vertices. Find the minimum and add it to the tree. We need to find the minimum cost edges for the new vertices, that is, which are not already included into the graph. For that new vertices, we are going to find the edges with minimum costs, and we are going to add those edges to the minimum cost spanning tree. We keep repeating step 2, that is, this step is to be repeated till we get a minimum cost spanning tree. So the time complexity of Prim's algorithm is big of E log V or big of V log V. Here E is the number of edges and V is the number of vertices. Right. Now here you can see how algorithm works. So initially we are given a graph. So this is the graph given for us and the weights assigned to that edges. And from this graph, I want to find a minimum cost spanning tree using Prim's algorithm. What is the first step in Prim's algorithm? First, we need to select a vertex randomly. So that vertex may be A or C or B or T or G. So first we selected the vertex B. So here this vertex I selected. Then I need to select a minimum cost. I need to select a new vertex which is incident on B and which is having a minimum cost. Now let us see what the edges incident on B. This is an edge incident on B and this is an edge incident on B. This is having a weight 10 and this is having a weight 4. Out of these two, which is having minimum cost? 4 is the minimum cost. So that's why we are going to add the vertex B to the minimum cost spanning tree. Now, 2 vertices are included in the minimum cost spanning tree. Those 2 vertices are B and T. Now, we are going to add one more vertex that may be incident on either B, one more vertex we want to include that should have a minimum cost edge either from B or D. Now let us see. Already this edge is added. Now we are left with this edge in B, and coming to D, this edge contains a weight 2 and this edge contains a weight 1. Out of these three, this is having 10 cost, this is having 2 cost, and this is having 1 cost. Out of these three, the minimum cost is 1. So we need to add the next vertex E. Right. So till now, 3 vertices are added to the minimum cost spanning tree. Those 3 vertices are D, D, and E. Now we are going to add one more vertex. That vertex we have a minimum cost edge from either D, B, or E. Right. Now here we are seeing from E. So here if you see, so if you see now, we have already completed this edge. We have already completed this edge, right? Now B, D, E are added. Now I want to add one more vertex. Now here this edge BC is having 10. This edge BC is having 2. And the edge incident on E, this is having a weight 6. Out of these two, which is minimum, 2 is minimum. So C is added. Right. Now B, D, C, E. 4 vertices are added. Now in the next step, we are going to add one more vertex. That vertex is having one A. Now let us see, this is having a minimum cost. Now here you can see from C, A is having a minimum cost of 3. Right. So that's why A is added to the minimum cost 3 here. Now the cost of this entire spanning tree is 10 units, which becomes a minimum cost. This becomes the minimum cost spanning tree for this graph. So I hope that you all understood the minimum cost spanning tree using Prim's algorithm. So first it starts with a vertex, and step by step it goes for adding the vertices by finding the minimum cost edges from the vertices which are already included into the minimum cost span. Thank you for listening.